Note, by the way, this is a very obtuse design. It's obtuse intentionally. People have proposed some really bad ideas for solving this problem, like ideas that laughably don't work. I've just silently made all those bad ideas fail in this design. So, what does it actually look like? Anyone hear about JSON in this place? JSON is like XML, but significantly less hideous. JSON is basically, you get the same results of XML, but you just evaluate it in JavaScript or parse it in JavaScript, and it just works. And you now have this huge, this would probably be like 5 slides in XML. Very small in JSON. But what it looks like is that the proxy is going to say to the attacker, hi, you have a connection, you're going to have a set of connections to 10.0.0.1. Connection 3 in there is going to have some sequence numbers, some acknowledgement numbers, some data to the browser, some browser state, some server state. Okay, fine, I ported TCP to JavaScript. What? It's a fun Saturday night. So, the ultimate question, how many DNS requests does it take to get to the center of your corporate network? Well, we can't use JavaScript alone. The proxy can cause the browser to open up a socket, and the socket's an iframe. But what's going to happen in there? Well, JavaScript can't do it. We need to get a Flash object. And we need to basically drive the Flash object with JavaScript. Now, there is some way to do this right in Flash somehow, but it turns out there's a really cool language out there called Hax. It's called Hax. I have to use it. It's a meta language. You can compile it down to Flash and JavaScript, and you can actually use Hax objects compiled to JavaScript from JavaScript, and the Hax objects can call their Flash equivalents. So Hax is actually a fantastic bridge between Flash and JavaScript. So I ended up writing all my stuff to it. So what I do is I compile a Flash movie. First off, the browser has to load the movie. And that's going to be loaded from 10.0.1 fooproxyhost.com, which is going to DNS resolve to the proxy's IP. Now, the first thing this Flash movie is going to do is going to say, I need a security policy that says I can do whatever the hell I want. And it is going to download that security policy, still same domain, from 10.0.1 fooproxyhost.com. Still, same IP. Everything is great. But we're going to make a TCP connection. And we don't want that to go to the proxy's IP. No, we want that to go to 10.0.1. So what do? We go ahead and we send an HTTP message to the proxy. And we say, hey, dude, next time you get a DNS request for 10.0.1, I want you to mess with it. And will you believe it? It totally will. The next time when we actually do a connect call to 10.0.1 fooproxyhost.com, we do a third DNS lookup, and that server replies, oh yeah, that's at 10.0.1. And then you win. At that point, you basically have a connection, you just got to manage data flows. This should not have been as tricky as it actually turned out to be. It turns out that when you have iframes, each iframe has its own JavaScript interpreter. They are running just like threads. Oh yes, I had concurrency bugs in my browser. Oh dear. Yeah, so the whole browser as operating system thing, yes, browser making me want to bang my head against the wall with Heisenbugs. Yes. Like, why am I dropping 1 out of 50 messages? Oh, because it hasn't yet completed that list. Anyway. So, what do we do for the data flows? Data is going to be received by Flash. Flash isn't going to do anything with it, but send it back into JavaScript for management. So it's going to go down into the browser DOM of the second level socket. What's going to happen is the bucket is going to visit each of its sockets. It's going to say, have you got any data for me? Have you got any data for me? Have you got any data for me? The bucket is going to aggregate all the updates from all the sockets, is going to send them in a huge batch in an HTTP update over to the proxy. The proxy is going to decapsulate this batch of updates, is going to hand them to the attacker. The attacker is going to be like, sweet, I got an incoming SSH connection. Here, let me start negotiating with that. Is going to create a TCP payload going back the other direction. That TCP payload is going to be received by a browser from the proxy. The payload is going to be sent back into each of the sockets, and the Flash object is going to pull the updates out and send it out each of the socket connections that have been set up. Like I said, totally trivial. Believe it or not, it actually works. I'm going to try to demo it, but I have to warn you guys, I have no idea. Oh my God, my net is actually working. I think I can even demo this for you guys. All right, let's try this out. So we're going to go over to bucket, not Mallory foo. So we're going to go over to this. Maybe. Oh, come on. I hate when live demos fail. And it was working so well, too. Oh, wait, hang on. You know what? It's TorqueCon. I totally need to do the live demo here. Anyone else would be like, nah, I don't need to do live demo. No, you guys, you need to see the real deal. So I'm going to make this happen for you. Anyone got like Jeopardy music or anything? All right, let's see what I can do here. There we go. So let's try this, try that. Oh yeah, we got bucket. So now, we're going to go ahead, find out an IP address. Okay, 66. So we're going to say, this is just a little weird interface that's been shown. So we're going to go, we're connecting to the proxy. We're telling it, please give me a connection to 66.240.226.139, port 22, protocol 6. Because, hey, we might be supporting UDP someday. So we hit enter. Oh, look, we got a socket that opened up. It's opened up an alert for no reason. Oh, wait, it's socketed, it's connected, and wait for it. Oh, look at that SSH login right there. Oh, that's right. Anywhere else I'd fail the demo here, All right, but what are domains? You know, you might notice I had bucket.notmallory.com talking to like, 66 whatever notmallory.com. How come those two could talk? Well, it turns out normally they couldn't because they're from different domains. But there's a little exception in the same origin policy. Two hosts, if they share the same parent domain, they can opt in to join that same parent domain. So foo.notmallory.com and bar.notmallory.com can say, we both trust Not Mallory. Let us talk to each other. That's right, I'm using the same origin policy to pwn the same origin policy. So that's it, a little bit of housekeeping. That's a TCP and JavaScript implementation. But what about the attacker? How is the attacker supposed to interact with all of this? Is the attacker going to go ahead and type NC 127.01, 12345? Oh no, I got much more fun ideas. So, was there anyone here who was in my original talk like 7 years ago about Slurp? Okay, check this out. Back in the day, I think it was like 2000 or 2001, I gave a talk on really, really evil things you could do with SSH. And one of the things that you could do is you could run PPTP, the VPN protocol, over SSH. Yeah, so I was actually using Slurp to do this. Slurp was old school when I gave the talk 7 years ago. Now it's being dug up from the grave. You actually can't find this code on the internet right now. I had to pull out an old hard drive. Dear God. So, Slurp is fantastic. It is basically 1995 called They Want Their